Assalamualaikum warahmatullahi wabarakatuh. Topik 2.1 Hydrostatic fluid pressure. This is the list of reference that you may refer for this topic, fluid pressure. Topic fluid pressure have 10 subtopics that related to hydrostatic pressure. Learning outcome. First is explain the concept of pressure, pressure difference, and then determine pressure head, pressure gauge, and also absolute pressure. And lastly, apply the concept of pressure with pressure measurement. Okay, as the introductions, you need to know on fluid statics. Fluid static is actually deal with a fluids with not in motion, mean no movement, or we call it as stationary. When the fluid is static, it's considered or it means that there is no shearing stress and the velocity is zero. Okay, what pressure is involved? It is only normal stress. Okay, let's recall your knowledge on physics. Okay, you learned previously how we measure pressure. Pressure is force divided by area. So can compare with the situation of the boy. When the boy is standing, the mattress is sink. This is because of the area is low. When the boy is laying on mattress, the mattress is not sink because the area is large. So area is large. Pressure is inversely proportional to the area, means that when the area is low, the pressure is high, the pressure increase. When the area is increased, the pressure is decreased. Okay, then we want to measure pressure of a liquid at a particular depth, which is H. Okay, normal formula for pressure is force over area. Okay, in terms of measure a liquid at a particular depth, we use formula weight divided by area. The force we change to weight. So how we calculate the weight? We use density times gravity times volume. And then the volume is calculated as length times base times the height. Area is length times the base. Okay, we can cancel the length and also the base. And the derived formula is pressure equals to density times gravity times H. G is actually the constant. G is 9.81. Okay, let's go through the examples. The figure given shows three non-mixing liquid, which is X, Y, and Z, in an enclosed tank. So the liquid is different, means it has different density. So we apply the new derived formula that we previously, which is P equals to rho GH. Okay, so for pressure at X, we use the density of X and constant of 9.81 and the height is 8. Okay, if we want to calculate pressure at Y, we need to calculate from the above to the bottom. So we need to add pressure X, then we calculate pressure for Y. Using the height is 3. Okay, same goes to pressure at Z. We need to add pressure Y and then calculate pressure for Z. The pressure of Z is 240.345 in unit kilopascal. Okay, another example is on hydraulics. A hydraulic press has a ram of 20 cm diameter and the plunger only 3 cm diameter. It is used to lift a weight of 30 kilonewton, or kilonewton we can change to newton, times 1000 and find the force required by the plunger. So we need to find the force here. So the concept here, pressure at left must be same for pressure at right. So here we have P1 equals to P2. And then how we calculate pressure, it is F1 over area 1 divided by F2 over area 2. So F2 we want to find. Okay, first we calculate the area of the ram. We are using pi d squared over 4. And then we get the area of ram is higher than the area of plunger. Substitute into the formula and we get force at the plunger is 672.2 Newton. Okay, then for concept of pressure, we have stress. Stress is force per unit area. For hydrostatic pressure, we have normal stress. Normal stress is the normal component of force acting on a surface per unit area. Means the normal force is acting on a surface, represented by Fn. Okay, for hydrostatic, there is no shear stress. Means shear stress is 0 because the fluid is not moving. And then for pressure, pressure is the normal stress in a fluid at rest. Okay, then pressure also has various units. Let's go through on that. For pascals, we have 1 pascals is equals to 1 Newton meter per meter square. And then pressure also can be calculated as 1 bar or 100 kilopascal. For atmospheric pressure, it is 1 atm or 101.325 kilopascals. And then we have also another units of Newton per cm square and also bar and atm. Okay, then picture of the right, we also can compare pressure for big man or also thin man. So this man has different mass. So for this one, we calculate using formula of P equals to weight over area. So which one has higher pressure? Of course, the bigger man. The pressure is 40 kilopascal compared to thin man only 20 kilopascals. Okay, statics rules apply to fluid at rest. Hence, there will be no shearing forces acting. So, fluid at rest, no shearing force. And all forces exert between the fluid and a solid boundary. When we have solid boundary, the force must be perpendicular to the boundary. Okay, for examples, we have this boundary. So the force is perpendicular to the boundary, 90 degree, perpendicular. Okay, pressure are related to Pascal law. So we need to prove the Pascal law for pressure at a point. It can be established between the pressure Px in the x directions, Pz in the y directions, and P naught is normal to any plane inclined. So we have this prism inside the water. So we need to prove that Px is equals Pz and equals P naught. Okay, this means that pressure is same at all directions. Okay, let's see how we prove it. Okay, we need to taking summation for the force in z directions. So the sum of force z is equals to 0. So how we calculate this? We are using the formula of P divided by P is force over area. So force is pressure times area. So this is pressure Pz times the area. Area at Pz. Let's see from the picture above. So this is Pz. The area of Pz is B times the delta x. And then we need to minus the P naught. Why it is minus? Because it is from different directions. So here we have P naught. So the area of P naught is B times delta S. So here B times delta S and cos theta. This is simple trigonometrics. And then we have weight. We need to minus the weight. The weight, how we calculate the weight? Weight is rho GV. So this is the volume of that prism, triangles. Half times delta x times delta z times b. And then we substitute into the cos delta x over delta s. This is trigonometric. Cos is adjacent over hypotenuse. Substitute into the formula, we can cancel the delta x. And then we get Pz delta x equals to, we bring this one to the right, it is equals to P naught delta x. So we can cancel delta x, we get Pz equals to P naught. Okay, same goes to the x directions. We can substitute into the formula. Sin is opposite over hypotenuse. And we can cancel the delta s. And lastly, we get Px is equals to P naught. And we can conclude that Pz equals to Px equals to P naught. And this follow Pascal law, where the pressure at any point in a fluid is independent of its directions. Okay, thank you.